Welcome to the lecture on liquid fuels. Liquid fuels are those combustible or energy generated molecules that can be harnessed to create mechanical energy, usually producing kinetic energy. The thermal efficiency of liquid fuels is higher than solid fuels. Coming to classification, liquid fuels are classified as primary liquid fuels, or they can also be called as natural liquid fuels. And as secondary liquid fuels or artificial or synthetic liquid fuels. Primary liquid fuels examples are petroleum, or this can also be called as crude oil. And examples for secondary or artificial liquid fuels are petrol, diesel, kerosene, petroleum ether, etc. Next, properties of liquid fuels. The first property is density. Density is the ratio of fuel mass to volume, and the unit for density is kilogram per meter cube. So using the property density, we can measure quality and quantity of the fuel. Next property is viscosity. Viscosity is the measure of resistance to flow. And the viscosity decreases with increase in temperature. Viscosity is used to study the usage and storage of the fuel. And third property is flash point. Flash point is the lowest temperature to which fuel can be heated, so that the vapors gives flash when flame is passed over it. And if we take the furnace oil, the flash point of furnace oil is 66 degrees centigrade. And the next property is pour point. Pour point is the temperature at which the fuel start flowing, or we can also say it is the lowest temperature at which fuel can be pumped. And the next property is calorific value. As already we have discussed in the earlier videos, calorific value is the amount of heat or energy produced by burning unit mass of fuel. So that means what? It is heat or energy produced. That means production of heat or energy. Here we will have high calorific value and low calorific value. High calorific value means vapors are fully condensed. Low calorific value means vapors are not fully condensed. Specific gravity. Specific gravity means it is the ratio of weight of oil volume to weight of same water volume. At given temperature. If we take the specific gravity of water is 1. The specific gravity can be measured using hydrometer. Sulfur content. The amount of sulfur content depends on source of crude oil. And the presence of sulfur in the crude oil forms sulfuric acid, which corrodes the furnace. Next property is ash content. Ash is the inorganic material in fuel, and this ash content will be typically from 0.03 to 0.07%, and the presence of ash content in the fuel will damage the materials and equipment at high temperature. Not only that, it also corrodes the burner tips. And the ninth property is carbon residue. Carbon residue means it is the tendency of fuel to deposit a carbonaceous substance on hot furnace. For residual oil, the carbon residue will be greater than 1%. And the last property is water content. So, the liquid fuels will contain less amount of water content, and this water content may be available in or may exist in free form or in emulsified form. The main impact on flame, and it will also affect the furnace also. So these are the properties of liquid fuels. Next, advantages of liquid fuels. Liquid fuels will have high calorific value. There will be no problems like ash, dust, clinkers, etc. And transportation is easy. Storage is also easy. And better control over combustion. And less furnace is required. The space occupied will be less. And it is mainly suitable for internal combustion engine. We will discuss in detail about this internal combustion engine while discussing the knocking of petrol. Next, disadvantages. The main disadvantage is cost of liquid fuel is high when compared to solid fuel. So cost is high when compared to solid fuels. Next disadvantage is greater risk. Next is special type of burners are required and special storage also. Next, coming to the topic petroleum. The word petroleum is a Latin word which came from two words, petra and oleum. Petra means rock, oleum means oil. That means petroleum is the compound which is obtained from rocks, in between the rocks which are existing under the earth. So petroleum is a dark greenish brown viscous oil. It is found deep in Earth's crust. It is a complex mixture of aliphatic and aromatic hydrocarbons. It contains traces of heavy metals such as iron, cobalt, nickel and vanadium. And coming to the average composition of petroleum: carbon 80 to 87%, hydrogen 11 to 15%, sulfur 0.1 to 3.5%, nitrogen 0.4 to 0.9%, oxygen 0.1 to 0.9%. Next, coming to the classification. So petroleum is basically classified as paraffin based type, asphalt based type, mixed based type. Paraffin based type means mainly contains saturated paraffins. Saturated paraffins starting from methane to the saturated paraffins containing C35 carbon atoms, C35H72. And asphalt type. Asphalt type means they mainly contain cycloparaffins and naphthalenes. Mixed base type means they contain both saturated paraffins and naphthalenes as well as aromatic compounds also. Next, origin of petroleum. Origin can be explained by two theories, carbide theory and Engler's theory. Carbide theory can be called as inorganic theory and Engler's theory can be called as organic theory. Now coming to the carbide theory. According to this theory, carbides which are formed by the reaction between carbon and metals at high temperature and pressure are acted by steam to give hydrocarbons. So, reaction between carbon and metal gives rise to CaC2, calcium carbide, as well as if you take the reaction of carbon with aluminum, so CaC2 means 2C, it gives rise to aluminum carbide Al4C3. This is called as aluminum carbide. So here the calcium carbide formed reacts with water, forming calcium hydroxide and acetylene. So this is calcium hydroxide and this is acetylene. So already I wrote here, this is calcium carbide. And aluminum carbide formed reacts with water, forming aluminum hydroxide plus methane. So 12H2O, 4AlOH thrice. So this is methane and this is aluminum hydroxide. So here we are getting saturated hydrocarbons and unsaturated hydrocarbons. The unsaturated hydrocarbons will again react with hydrogen, forming saturated hydrocarbons. So here what is unsaturated hydrocarbon we got? Acetylene. So this acetylene again reacts with hydrogen and forms ethylene. ethylene will further reacts with hydrogen and forms ethane. Not only that, sometimes these unsaturated hydrocarbons may undergo polymerization. Ethylene, on polymerization, it will form benzene. Similarly, the ethylene C2H4, this on polymerization will form cyclohexane. So this is how various hydrocarbons are formed. This theory will provide the proof for inorganic origin only. But here the presence of sulfur or nitrogen cannot be proved. And not only that, the presence of optically active compounds can't be visualized by this theory. Next theory is Engler's theory, or this can also be called as organic theory. According to this theory, petroleum generated from aquatic animals and seaweeds under the influence of high temperature and pressure, and this is supported by geologists also. How this is supported by geologists means because of presence of sulfur and nitrogen, fossils, brine and optically active compounds. All these were found to exist in the petroleum. So this was supported by the geologist. Experimentally proved by distilling of fish when a petroleum resembling liquid is obtained. This theory does not explain the availability of chlorophyll. In the next video, we will discuss about the mining and refining of petroleum. Thank you.